Hi, this is sample question number 1 from SOA exam FM, Financial Mathematics. Bruce deposits $100 into a bank account. His account is credited interest at an annual nominal rate of interest of 4% convertible semi-annually. At the same time, Peter deposits $100 into a separate account. Peter's account is credited interest at an annual force of interest of delta. After 7.25 years, the value of each account is the same. Calculate delta. Well, first I'm going to start off by writing the amount functions. Amount for Bruce at the end of teeth here would be 100 times 1 plus 0.04, since it's convertible semi-annually. This is what I get. And I'll write a similar function for Peter. So the amount in Peter's account at time t is equal to what he starts out with. And it says he's credited interest at an annual force of interest of delta. And since this delta is assumed to be constant, we have this simplified function as such, e to the power of delta t. And now, after 7.25 years, the value of each account is the same. So what we can do is to set these two equations equal to each other. And you can see that the $100 is irrelevant because they cancel each other out. And let's just move up here. 1.02 to the power of 2t is equal to e to the power of delta t. And what I'm going to do is I'm going to take ln of both sides. Oops. I'm going to take the ln of both sides, ln of e delta t, and you'll see you can bring the 2t down. This is one of the laws of our logarithm. And ln and e is going to cancel each other out, so you're left with delta t. And another interesting thing you'll find is that the t's will cancel out. So we're left with delta is equal to 2 ln 1.02, and if you plug it into your calculator, you'll get 0.0396. So the answer is C. Another way you could have approached this question is to realize that if Bruce and Peter start out with the same amount, $100, and after 7.25 years, if their account balances are the same, then that means that their annual effective interest rates have to be equal to each other. So in this case, we would have done, Bruce would have gotten this much interest at the end of 1 year, and Peter would have gotten this much, e to the delta t. And here simply you can take ln of both sides, as I've done previously. Oops. As I've done previously, and we would have gotten, because ln and e will cancel each other out, ln of 1.02, which is again 0.0396. So this question would have been a little simpler if you realize this fact, but either way, you would end up with the same answer.